Hey everybody, I want to talk to you about binomial random variables or binomial distributions. Um, yeah, we'll see that I'll use those terms largely interchangeably. They don't mean exactly the same thing, but they're pretty similar. I also want to talk a little bit about distributions or discrete distributions in general, and we'll do that when I start talking about the computer and with computer and calculator functions. So let me start this off by giving you the basic discrete random variable, which is binomial. When I say the basic one, it's not the simplest one, but it is the most common and most important by a huge margin. So here is what a binomial random variable is. So I guess before I describe this, the classic binomial random variable is flipping a coin. So that's the context that you want to think of this in. So in a binomial random variable, you have only two outcomes that we're going to call success and failure. There's no like third option. And by the way, success is just the thing that we're counting, and failure is the thing that we're not counting. So let's say I was flipping a coin and I wanted to count heads. Heads would be success and tails would be failure. Notice there's no like moral implications there, no positive or negative. It's just success is the thing we're counting and failure is the thing we're not counting. All the trials are independent. So the outcome of one does not affect the next, which coin flipping, right? You flip a coin, it affects that flip, but not the next one. There is a fixed probability of success that we're going to call P. So in case of coin flipping, it'd be 50-50, right? 50% chance of success, so P is 0.5. And there is a fixed number of trials in which we are counting the successes. So in this case, I would have to flip the coin, 38 times and count how many times heads came up, right? So if that's what I was doing, if I was flipping a coin 38 times and counting how many times heads came up, then I would have a binomial random variable there, which would vary between 0 and 38, right? Then the minimum number of times the heads could come up would be 0. I could get 0 heads. And the maximum number of times would be 38. And then within that, we would have a probability for each outcome, right? There would be a probability of getting 1 head, and there would be a probability of getting 2 heads. Now, in this case, the most likely outcome is that I get 19 heads, right? 50% chance of success, 38 trials, 50% of 38 is 19. That is going to be important, which we will keep this in mind for calculating things in just a second. So let's do an example here. I have conscripted LeBron James to shoot free throws for us. He's a career 74% free throw shooter. So he makes 74% of his free throws, at least in games. He's probably better than that outside, but we'll just assume this is in games. And he is shooting 10 free throws. And I want to find all of these things. I want to find the probability that he makes exactly 6. Oh, by the way, I'm thinking of make a free throw as success. I hope that's obvious. I want to find the probability that he makes exactly 6 free throws, probability that he makes less than or equal to 6 free throws, greater than 6 free throws, and greater than or equal to 8 free throws. So before I do that, I need to show you. So we're going to do this on the calculator, and I will show you how to do it on Excel and Sheets. And then for the next ones, I'll probably just do Excel or just do Sheets, because they're very, very similar. They work almost exactly the same. Yeah, so let's do that. So before I do that, let me talk about how to do this on the calculator. So the calculator it works fine, right? It does work fine, but it's a little bit confusing. So we have two suffixes of PDF and CDF. Let me go ahead and share up the calculator here. That is not how I share that. Where's my share button? All right, so here's my calculator. And I want to do a binomial random variable. And so I'm going to go show you where they're at. You can find them in distributions, which is the second function of the vars or variables button. All right, so if I go second vars, that brings me to the distributions menu. We will use a good chunk of these in this course, but binomial is the one I want right now. So I've got binomial PDF and binomial CDF. PDF stands for probability density function. It is what you will use if you want to know what the probability of getting a certain number of successes is. in a particular binomial distribution, which I'll show you how to put in just a second. CDF stands for cumulative density function. And so that calculates the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability all the way up to whatever you say, and adds them all up for you. So it's like the cumulative relative frequency, right? If you think back to our previous topic 1, it'd be like it's like relative frequency for PDF and cumulative relative frequency for CDF. It turns out that we will be using CDF the vast majority of the time. Most of the time we'll be using CDF, and PDF will be only for when we've got just equal to. So if I go look at my whiteboard here, so PDF is for equals only, and CDF is for all of the inequalities. So let's see what we can do here. So here's the basic idea. The way you want to think of this is that CDF means less than or equal to. Let's actually, before I go any further, let's do example A. So this is just equals, right? It's not an inequality, so it's an equals. So I'm going to use PDF, and I'm going to use binomial PDF because I know this is a binomial random variable because of all the things I mentioned before. All of this stuff is true here, so I've got a binomial random variable. So if I go to my calculator, let's show that up. I'm going to do binomial PDF, which again, if you've forgotten, was second bars. It's in distributions. I'm going to go to binomial PDF. There it is, and it's asking me for the number of trials, probability of success, and then the X value, which is the number that I am interested in finding, which in this case is 6, right? I want to know what the probability of getting 6 successes was. So the number of trials, LeBron is shooting 10 free throws, so I've got 10 free throws. His probability of success is 74%, and you have to put it in as a decimal. Calculator won't like it if you put in something bigger than 1. And X is the number of successes that I'm trying to calculate. So in this case, 6 successes. Put that in. If you don't have that previous screen, then the thing that when you hit binomial PDF in your calculator, what might happen is that you just get this screen that just says binomial PDF and puts a left parenthesis. You have to type in this stuff in this order. NPX, number of trials, probability of success, number of successes you're interested in calculating. You have to put it in that order, then hit enter. So there we go, 15.76% chance of success, or of getting 6 successes exactly. All right, so let's go put that down. So this was, let me see, 15.76%. So when he shoots 10 free throws, there is a 15.76% that he makes exactly 6 of them. No more, no less, just exactly 6. That's what PDF calculates the number of getting that, or calculates the probability getting that particular number of successes. On the other hand, what if I want to know the probability that he makes 6 or fewer? So no more than 6 successes. Well, that's what CDF does. Remember that CDF will do the exact same thing as PDF, but instead of just telling you the number at, in this case, 6, or the probability of getting exactly 6, it'll tell you the probability of getting 0, 1, 2, 3, 4, 5, or 6. And then add all those up for you so that you don't have to calculate them all individually and then add them yourself. It's actually quite convenient. CDF is a really nice function, so let's do that. It's going to look very similar. We're going to go back to the same place to distributions, and we're going to go to, instead of binomial PDF, we're going to do binomial CDF. And it's going to ask us for the same things, right? Because it's asking, it's basically, it's doing the same stuff, right? So we still have 10 trials, still have probability of success of 74%, X value is still 6. We're going to paste that in, and notice it's much bigger. Well, I guess it's a little bit bigger this time, 24.79%. So let's go write that down. Okay. So those are your basic functions. Your calculator will only do equals or less than or equal to. It won't do anything else directly. You kind of have to force it if you want to do something else like that. So for instance, let's say I wanted to find the probability that x was greater than 6. All right, I want to go to the next page and I will show you why. 2 pages from now. This is the one I want. So here is a huge tip for you that makes this a lot easier. I want to write out all of the outcomes. You can, like, if there's 1,000 different outcomes, you can just write out the area you're interested in. I want to write out all the outcomes, and I want to circle the ones that we are interested in. So we were interested in the probability that x is greater than 6. Now our calculator won't do greater than, like I said, CDF just does less than, or less than or equal to. So greater than 6 is not including 6. 6 is not greater than 6. So 7 to 10, right? Those are the ones that we want. So what I'm going to do is note something important here. So all of these together have probability of 1 total. Probability equals 1. Or 100%. Right? There is a 100% chance that one of those things is going to happen, right? You can only make 0 or 1 or 2 or 3 or up to 10 free throws, right? That's all the possibilities that there are. So one of these outcomes is going to happen. So what I can do is I can pick out the ones that I don't want and cut them out. Right? So I can say, well, okay, I don't want these outcomes. And that will give me only this stuff left. So here's the trick. I want to do 1, which is the total probability, minus the stuff that I don't want. So in this case, I'm going to do 1 minus, so 1 for the probability of everything, and then take away the probability of the ones that I don't want, which I'll call CDF of 6, right? So I'm going to chop out 6 and less, and that will leave me just 7 through 10, which is the thing I want. All right, so that's the basic idea of what I'm going to do here. I'm going to erase this so that I can use it again without having to rewrite numbers 1 through 10. Okay, so when I'm looking for the probability that x is greater than 6, I'm instead going to do, sorry, I need a pencil. I'm going to do 1 minus the probability that x is less than or equal to 6. Right, and then we're going to find out what that is. So I need to go to the calculator and do 1 minus the probability that x is less than or equal to 6, which is binomial CDF of 6. So let's go type that in. So still 10 trials, 74% chance of success, and our x value is still 6. And we get 75.21%, right? Which you might notice is just the complement, or it adds up to 100% with our previous answer, which I hope makes sense, right? If I go look at what we had, we said that 100% is this whole thing. And so I specifically asked about, in the previous part, I specifically asked, like, what's the probability of getting 6 or fewer? And then the next part, I asked, well, what's the probability of getting more than 6, right? And those two things are clearly opposites of each other in this case, right? We call those complements of each other. They're complementary because they add up to 100%. And so since we had already found probability of 6 or less, we could just do 1 minus that to get probability of 7 or more, which is easy enough. I'm actually hoping that everybody caught that I was trying to help you feel clever there by noticing that. So this is about equal to, what do we say this was? 75.21%. All right, so now let's do this without just being able to look at the previous answer and see what we get. So here I want to do probability that x is greater than or equal to 8. And here is where this advice comes in really handy. If I want to know the probability that x is greater than or equal to 8, I am going to box the ones that I want to count, right? I want 8, 9, or 10, because that's where x is greater than or equal to 8. I want to exclude 0 through 7. So I'm going to do 1 minus CDF of 7, right? 1 for being all of the probabilities, and then minus the CDF of 7 being taking away 0 through 7 so that I can leave myself with just the ones that I wanted, 8, 9, and 10. So let's go to the calculator. Where's my mouse pointer? There it is. Let's go to the calculator. So I want to do 1 minus binomial CDF same number of trials and probability of success, but I'm trying to do 1 minus CDF of 7 because I want to throw away 0 through 7, leaving move 8 through 10. And we get 49.58% chance that you will make 8, 9, or 10 free throws. 49.58. Okay, let's go put that down. Okay, so that's how you can do this in your calculator. Let me go, I'm going to answer these same questions. We're going to get the same answers for them, obviously. I'm going to go do that in Sheets. I need to pause the video to do that because I didn't think to open Sheets, and I'll be right back. All right, I got my Sheets thing open, so let's go look at that. All right, so the command that you want to use in Sheets is called binom dist, so for binomial distribution. So equals binom, no, is it not typing? There we go. So we have some choices: inverse, distribution. As far as I know, these two are the same thing. I don't know why they have two of them. This is the classic one that I'm used to using. I think this is the same thing though, yeah. So notice that what it wants is the same exact thing that the calculator wants. It wants the number of successes, the number of trials, and the probability of success. So let's put that in, right? So if I'm doing the first one, number of successes, 6 successes, number of trials, we have 10 free throws, probability of success, 74%. And then there is one more thing here that asks for cumulative. And what it's saying here is, do you want to use the cumulative distribution or just the probability density function? And if you want to use the cumulative distribution, you call this true. If you want to use the probability density function, you use a false. So in this case, for just x equals 6, I just want PDF. So cumulative is false. That word is false. And then it finds the same number that we found earlier. No problem. Okay. Now, let's see if we wanted to do the cumulative one, probability that x was less than or equal to 6. So same thing. I know lists of with 6 successes and 10 trials with a 74% chance of success, cumulative true. Right? So same thing we found, 24.79%. Okay. What about if we wanted to go above 6, right? Probability that x was greater than 6, so 7, 8, 9, or 10. We do exactly the same thing. Equals 1 minus binom dist of 6 successes in 10 trials with a 74% probability of success. and cumulative true. Right, so exact same thing we found. Sorry, I hit page down. Exact same thing we found before. And then same thing, we want to do greater than or equal to 8. So I want to do 1 minus CDF of 7. So equals 1 minus binomial dist of, we say 7 successes in 10 trials with a probability of success of 74%. True. No, that's not a word. That's the one we want. So we want CDF there, and we get the exact same thing we found. So 49.58. So there you go. That's how you do this in Sheets. And I will very, very briefly. So notice that, whoops, what the heck? There you go. So notice those are the same numbers that we found, 15.76%, 24.79, etc. I will very, very briefly show you how to do this in Excel. Let me get my Excel sheet going. That's when I put a homework problem. And it is, I think, exactly the same commands. Let's see here. So if I do equals binom, it's dot dist here, binomial distribution of, and then it's going to ask for the same thing. Number S is number of successes, trials is number of trials, probability of success is B, and then cumulative true or false, depending on whether you want the cumulative or cumulative density function or just the density function. So number S, number of successes, 6 successes. We had 10 trials, probability of success, 74%, and cumulative false. False. If we are doing the first problem, and there you go, 0.157, 1576, just like we found before. And the other ones are exactly the same, right? There's literally no difference. I want cumulative density function equals binom.dist with 6 successes, 10 trials, 74% chance of success, and true, right? Same number we just found. So there you go. It's a binom dist. That is the command you want in Sheets or Excel, and in the calculator, the TI-83 or 84, you want to go to second function of variables, which is distributions, and then go look for the one you're looking for in this case, binomial PDF CDF. All right, we're going to learn about 2 other ones. We'll learn about a very, very simple distribution in the next video, and then we will learn about Poisson after that. So for now, I want to go ahead and stop the video there, and I will see you guys in the next one.